Good morning, class. This is Mr. Roberts at Shasta High School, and today we're going to be continuing our discussion of techniques for solving equations. And two of my favorites today, right? Actually, I'll just say one: fraction busters. I really like rewriting equations by using the idea that, of course, these properties of equalities exist. If I multiply both sides of the equation by the same thing, I get an equivalent equation that has all the same solutions. And I can use that to my advantage to basically remove all fractions I see in an equation. So we'll be getting to that in just a minute, but let's start first of all by considering this equation. So this equation, right, it's not bad. I can see that I could rewrite part of it using the distributive property, and I also see that I could combine some like terms, etc. But one of the things that I want to point out is that this equation, right, has all of these decimal values, right? You can see the 0 0.4, 3.4, and the 0.2. And what I can do is I can use a property of equality, right? I can use the multiplication property of equality to eliminate the decimals. And this is kind of building up to the fraction buster ideas. I want to point out that in this equation, there are four distinct things that I would call three terms. The left-hand side only has a single term. This is a term, right? And even though inside of, or part of that term, there is one of the things that's being multiplied does have a subtraction thing, that is all contained within that term because there's nothing plus or minus to that term itself. So there's one term on the left-hand side. The right-hand side has this term and it has this term. I probably should point out that I guess it could be a plus minus, but this term, this negative symbol, is part of that term. Now I go through the time of pointing out the terms because you're going to hear me say a lot that it's important that we multiply each term on both sides by the same value. And for this one, we're going to start with the number 10. I'm going to multiply, quite intentionally, both sides of this equation by the number 10. On the left-hand side, I'm going to multiply by 10, and on the right-hand side, we are going to multiply both of these terms, right? This term and this term by that number 10. So the beautiful thing is on the left-hand side, when I do that, this simply becomes 4 times the quantity of x minus 2. On the right-hand side, when I multiply both of my terms by 10, it becomes 34 minus 2x. So visually, this is a big deal to me, right? Multiplying both sides by 10 got to a point where I'm not dealing with decimals anymore. I just have these values. Solving this is something that I think we're pretty good at. I'll just quickly do that. I'll rewrite the left-hand side using the distributive property. I'll add 2x to both sides. I'm adding 2x to this side. And you can see I clearly added 2x to this side because negative 2x plus 2x is going to be no x's. I'll add 8 to both sides, be 42. And then I will divide both sides by 6. And when I do that, I get x is 42/6, or better yet, x is just the number 7. So you can see in this first step, right, I multiplied both sides by 10. I used one of my properties of equality and obtained an equivalent equation. In the next step, I rewrote the left-hand side using the distributive property. After that, I added 2x to both sides, and then I added 8 to both sides, and then finally I divided both sides by 6. Two equations are considered equivalent if all of their solutions are the same. I'll star that. Two equations are considered equivalent if all of their solutions are the same. This is optional for your notes. There are several ways to change one equation into a different equivalent equation. Common ways include adding or subtracting the same number from both sides, or multiplying or dividing both sides by the same non-zero number. And this keeps coming up. Let's keep thinking about that. We want to make sure that we're dividing by non-zero numbers, because if we ever divide by zero, remember we get something that's undefined. All right, let's consider this equation. Certainly a mess, and I think I'm going to use the exact, almost the exact same technique as the last problem, except this time instead of multiplying by 10, I'm going to multiply by 100, because I notice over here, right, this, if I multiply this by 100, it would cease to be a decimal. So if I take a moment and focus on the number of terms I have, on the left hand side I have 1, 2, 3 terms, and on the right hand side I have 1, 2, 3 terms. And what I'm going to do is I'm going to push across a factor of 100 across every single one of those terms on both sides. So when I do that, the first term on the left hand side is going to become negative 750 x squared plus 480 x minus the number 30. Yeah, minus 30, because that would make 3 and then 30. So again, every single value got multiplied by 100. It's easy for me to do that because I'm just moving my decimal place 2 places to the right. Let's do the same thing on the right hand side. Multiply by 100. This is going to become 250 x squared. And then I'm going to have plus 1002, and I'm going to have minus, that's going to be 1000 x squared. Okay, I think the next thing that I want to do is I'm going to focus on the fact that I've got 250 x squared positive and negative 1000 x squared on the left hand side, and when I combine those, it's going to become, quite conveniently, this will be but that was a negative, it's going to become negative 750 x squared. And I think you know why I said conveniently, because over on the other side I had this positive 750 x squared plus 480 x and then minus 30. So because these are exactly the same, they're both negative and they're both 750 x squared, negative 750 x squared, I can add that to both sides. And if I add positive 750 x squared to both sides, those two terms cease to exist, and the equation collapses to 480 x minus 30 equals 1020. 480 x equals, I'm going to say 1032. I just added 30 to both sides. Now, I want to say that the reason why I prefer to take this step and get rid of the 100 is I don't need a calculator. I'm not using a calculator. These numbers are easy numbers for me to work with, except for the next ones. So I think it simplifies the workflow, and it's also easier for me visually